Hi everyone, so we're here to talk about finding the inverse of a quadratic function. So if you remember back from our first unit, when we talked about inverses, we talked a lot about switching x and y. When we were finding an inverse algebraically, that's exactly what we did. We switched x and y and solved for y. So we're going to do the same thing here. So my equation, f of x equals 2 times x minus 1 squared minus 3. I'm going to change that first to just y equals instead of f of x equals. I think it'll make my life a little bit easier. So when we want to find an inverse, we want to switch x and y, which I'm going to do first, and then solve for y. I want to get y by itself. Okay, that's going to be my goal. When I do that, I want to solve in the reversed order of PEMDAS. Okay, so I'm going to worry about doing any adding or subtracting, undoing first, then multiplying, division, then exponents, then parentheses. Which means the first thing I'm going to do is add 3 to both sides to get rid of that minus 3. I don't have to worry about in the parentheses yet because that comes last. So I get x plus 3 equals 2 times y minus 1 squared. Then now that I've done my adding and subtracting, I want to undo any multiplication or division. So I have a 2 times, so I'm going to divide by 2 to get rid of that. That leaves me here. Okay, so I've taken care of the multiplication and there was no division. Now I have to undo the exponent. In order to undo a squared, I'm going to square root both sides. And when I do that, I'm going to stick a positive or negative in front of that square root. That's really important for us, this positive or negative sign. If I think about squaring a number, if it's a positive number that I'm squaring, the answer is positive. And if it's a negative number that I'm squaring, the answer is also positive. So if I undo that, I could have started with a positive number, or I could have started with a negative number, so I need to include both. Now I have something that looks like this. And my very last step would be to get rid of that plus or that minus 1 by adding 1 to both sides. So my final answer, oops, I forgot my plus or minus. My final answer is plus or minus, and then a plus 1 at the end equals y. So this right here is the inverse of f of x. So the next thing that you need to be able to do, other than finding an inverse with an equation, is finding an inverse with a graph. So I've given you this graph of f of x. Again, if I want to find an inverse, I want to think about switching x and y. Here, what that means is I want to switch the coordinate points. So I've got all of these coordinate points that are nice ones. Let's see, this one, this one. I'm going to write all of those coordinate points down in a table. I'm going to start over here, and I'm going to copy all of these down. And I'm running out of room. That's probably enough. Okay, so again, if I want to find an inverse, I'm going to switch x and y, which means in my new table, all of these coordinate points are going to flip. This coordinate point becomes 5, negative 3. This one is 0, negative 2, and so on and so forth. So I'm going to take all of those points and plot them. I think the last one that I couldn't fit would be right here. So if you notice, I get this parabola that's on its side. This represents the inverse of f of x. Now one more thing to note about this. This graph that we just graphed fails the vertical line test. If you remember, back in our first unit, if you fail the vertical line test, what you have graphed is not a function. So I'm going to add that in here, not a function. I think that's important to notice, that even if your original graph, your original equation represented a function, the inverse might not. That's all for today.